2, 3.
What's up, team? Today we're going rhombus hunting. Just like our last two lessons, we have a set of conditions we're going to try to meet. So I've listed them here. I'm not going to talk through each of them individually. I'm just going to mention them, and we're going to see what we can see. So if we can find a quadrilateral that has 4 congruent sides, we have a rhombus. If we can find a parallelogram with 2 consecutive congruent sides, that means 2 sides that are next to each other and have the same length, and it also has to be a parallelogram, then we have a rhombus. If we can locate a parallelogram with perpendicular diagonals, boom, then we have a rhombus. Lastly, if we can find a parallelogram where one diagonal bisects a pair of opposite angles, that means some parallelogram with a diagonal, one of them, it bisects both sets of angles. That's all we would need to show, then boom, we have a rhombus. So here, I'm just going to show this by way of example, walk through this proof here. Not going to do a 2-column proof, just kind of show it with pictures. So first, we're trying to show that ABDE is a rhombus. ABDE. We're trying to show that that thing is a rhombus. It passes the eye test. You could convince me it is. Well, I don't know. Gosh, I shouldn't have said it quite like that. I need to be convinced that it is, even though it looks like it. So we have a whole bunch of given information. Let's see what we can see. First, AEF is equilateral. AEF, equilateral. Equilateral triangle means that all sides are the exact same length. It means that all the angles are the exact same angle measure. So these are all congruent. Additionally, these are all the same exact angle measure. Specifically, they're 60 degrees. We don't know the length of the sides, but we know the angles are 60 because they have to add up to 180, and they're all the same. Cool. DCB, triangle DCB is also equilateral. DCB. Now, we don't know that it's the same equilateral as the other one. Like, we don't know that it's the same length and whatnot, but we do know all the angle measures are the same. They must also be 60 for the same exact reason. Sweet. Side AF is congruent to BD. AF is the same as BD. Oh, that's interesting. So that kind of counters that point I just made a moment ago, how we don't know that the lengths of these triangles are the same. This means that they are. If AF and BD have the same length, well, then all 6 of these sides have the same exact length. So I'm just going to double up all these. So we have 6 congruent angles. We have 6 congruent side lengths. But again, we're still interested in this rhombus, potential rhombus. So let's keep hunting. Let's see what we can see. E is the midpoint of FD. Well, FD is here, and E is the midpoint. That's interesting. So that means that FE and ED must have the same exact side length, or same exact segment length. Okay. Let's take a peek at what's taking shape here. So far, in our potential rhombus, we have 3 sides that are congruent. That's awesome. It seems like we're on our way to having a quadrilateral with 4 parallel sides. I'm noticing here we have another one that says if we can show a parallelogram has 2 consecutive congruent sides, then we have a rhombus. We do have 2 consecutive congruent sides, but we've not yet demonstrated this as a parallelogram, so we can't quite lean on that. So our next course of action is to hope that the information we have left either shows us that we definitely have a parallelogram here, or we can show that AB is also congruent to these 3 sides. Either way is going to work for us. Doesn't really matter which one. Maybe both are true. Let's just do whatever one comes first to demonstrate that this is definitely a rhombus. Okay, next. AGC is isosceles, triangle AGC. Where is that? AGC is isosceles. So that means the 2 legs must have the same length, and it also means the base angles are congruent. So this angle is congruent to this one. Okay, I don't know that that actually helps us. It's true, but let's see if that helps us in any sort of way. And lastly, GBC is a right angle. GBC is a right angle. Okay, it's already in there. Okay. Well, what do we know about? Let's look at our isosceles triangle here and see what we can see. Let's take those chunks out and look at them separately. So we have G, B, A, and then we have G, B, C. And the course of action I'm going to take is I'm going to try to show that these 2 triangles are congruent and then use some CPCTC and see where that takes us. So we know GB is congruent to GB, of course, same line. GA and GC, we know that they're congruent because of the isosceles triangle claim here. And we also know that this is a right angle, and this whole thing is 180, so this angle over here must also be a right angle. So far it looks like we have angle, side, side, angle, side, side. We know that that's no good, but this is a specific case where it's a right angle. So we can use the hypotenuse leg theorem. If you don't remember that, check back a few units. Hypotenuse leg theorem is a special one that says if you have a right triangle, in which in this case we do, you just need to demonstrate that one of the legs plus the hypotenuse are congruent to one another to say that we definitely have congruent triangles. It's the one exception where the angle side side actually works. It's only when you have a right angle. So again, check out that video if you're not convinced of this fact, but it's definitely a thing. So now we have these two triangles that are congruent, meaning that, by CP, CTC, all the corresponding parts are congruent. The one that we care about, however, is that AB and BC are congruent. Because when we look at our picture here, if AB and BC are congruent, that means we're going to throw two little hash marks right here. Now, all of a sudden, we have a quadrilateral with four congruent sides. We still don't know that we haven't shown independently that it's a parallelogram, but because it's a shape with four sides, that satisfies this chunk. It's definitely a quadrilateral, and they're all the same length, so it's definitely got four consecutive sides. So we can now say this is definitely a rhombus. So I'd want you to write up a little something. I would say something like A, B, D, E is definitely a rhombus because it's a quadrilateral with four congruent sets. That'll do the trick for me. You don't have to write it up quite like that. You can explain it using your own words, using different things. You can say something like, you can get a little bit more mathy if you want. You can say AE is congruent to ED is congruent to DB is congruent to BA, therefore it's a rhombus. Cool, that's a win too. Lots of correct ways to explain these types of things. Okay, we went rhombus hunting. We were hoping this was a rhombus, and we demonstrated that it was true based on our given information, and we leaned on our understanding of triangles. We talked isosceles, we talked equilateral, we talked hypotenuse leg theorem, all these things kind of mixing up together. Okay, let's dive into some practice problems. Let me know if you have questions. You got this.